Hello everyone. In this tutorial, I just wanted to give you a brief overview of the periodic table and also give you some tips as to how to use it efficiently. I find that a lot of students, when they first start to use the periodic table to look up elements, the first way that they try to look up an element is pretty much going box by box and trying to match up the requested element to the symbol they're seeing in each of the boxes. And that is one way to find an element on the periodic table, but it can be very inefficient, particularly if the element happens to be pretty deep within the periodic table. And so really, the best way to be able to look up elements in the periodic table quickly is to have some idea as to where the different categories of elements are situated within the periodic table. So in order to understand that better, let's look at a periodic table and let's take it apart a little bit. The first thing that you should be aware of regarding the way the periodic table is put together is that obviously it looks like a grid. Okay, and as we all know, grids have columns and grids have rows. Okay, now the rows of the periodic table are called periods, and they're numbered 1 through 7 as shown here on this periodic table. Now the groups would be the columns. Now the way that the groups are numbered is sort of interesting. They've gone through several different numbering schemes in the history of the periodic table, and ultimately they've decided on the simplest, and that's what's really mostly in current use now. We pretty much just go from left to right on the periodic table, numbering each group sequentially. So group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now, that's the numbering scheme that is the least confusing and the one that we'll be using most often. However, your book does make mention of a somewhat older scheme where you have these groups in the periodic table that I'm circling in black. All right, these groups comprise what we call the main group elements. All right, so these main groups are given the designation A. In between the main groups, if you will, we have what we call the transition elements or transition metals, and those groups within the transition metals have Bs. Okay, but notice that once we get to group 8, there's a little funny business going on there, because basically any of 3 separate columns can be referred to as group 8B, and then notice also the group 1B and 2B happen to come all the way at the very end. And so, because of how confusing the B and A type of numbering scheme for the periodic table is, we will not be using it frequently. Some of the items in the in the textbook will make use of that numbering scheme, in which case you should actually find this particular periodic table within your textbook and use it to answer those questions, but by and large, we'll be using the numbering system that I've circled in pink instead, since it is the simplest. Now, the other thing to keep in mind regarding the periodic table is that it already groups the elements in a very logical way. As I'm sure you'll be aware of, basically the nonmetals are color-coded with yellow boxes. Okay, so any elements that are nonmetals are mostly found on the right side of the periodic table, with the exception of hydrogen, which is all the way over on the left in the topmost left corner. Okay, now the metals pretty much make up almost the whole rest of the periodic table. Oops, got a little carried away there. Almost the whole rest of the periodic table. Okay, now the metals can be somewhat harder to find just because there are so many of them, and they pretty much run almost through the entire span of the periodic table. But I think if you look carefully, you will see that there are some trends. Like, for example, one of my favorite trends to point out would be the following elements. This is copper, Ag is silver, Au is gold, Pt is platinum. Now, if you think of all of these elements, these are elements that are oftentimes used in coins or in jewelry, right, because they're valuable. Notice that they're all sort of clustered together in this little portion of the periodic table all by themselves. It's also true that a lot of the elements that are found in foods, like for example salt is sodium chloride, that's sodium, Na. We also have potassium, that's often found in the foods that we eat, also calcium. A lot of those metals tend to be clustered together too. It's also true, also magnesium can be considered one of those metals as well, and so those metals tend to also be found somewhat close to each other. In terms of the lower portions of the periodic table, down over here, all right, notice that these two parts of the periodic table, the lanthanides and the actinides, basically they've been pulled out of the periodic table. They really belong in that space after the elements lanthanum and actinium, respectively. And these portions of the periodic table have just been pulled out simply because if we put them back into their proper place, then the periodic table gets super duper wide and it sort of becomes difficult to use. And so for that reason, you'll see those two rows of the periodic table, the lanthanides and the actinides, always pulled out. It's also true in general that if we're looking for an element that is radioactive, then usually you're going to find it within the lanthanides and actinides, and it's also possible to find some radioactive elements down here as well. So if you know that the element that you're looking for is radioactive, then you want to look sort of further down in the periodic table. So the other thing to keep in mind is some of these groups tend to have specific names. Like for example, any element from group 1 is referred to as an alkali metal. From group 2, those elements are referred to as alkaline earth metals. Also group 17, we refer to them as the halogens. And then group 18, those are your noble gases. Okay, and we'll be discussing these elements and how they react and what combinations come together to give us compounds and which combinations won't. But in general, basically, that's sort of the main brief overview of the periodic table. One more thing I wanted to mention in here. All right, if we take a look here, all right, notice that there is a set of elements in boxes that are green. Now, if we take a look at the key to this particular periodic table, those elements in green are what we call metalloids. Now, metalloids have properties that are in between metals and nonmetals. And we'll discuss what that means in class. But the important thing to keep in mind is, at least in the beginning, we need to get you comfortable using the periodic table in such a way that you can find elements relatively quickly. Now, sometimes that can be a little bit challenging because sometimes the abbreviations for the elements don't seem to make sense when we consider the element name in English. Like, for example, Fe is iron. But the reason why the abbreviation for iron is Fe is because that is actually the first portion of the name of the element iron in Latin. And so for that reason, it's Fe. You also have to watch out for elements that have similar starts to their names, but then because of that, they have different abbreviations. Like, for example, I mentioned earlier, copper is Cu. All right, do not use Co for copper because Co is cobalt. All right, some abbreviations, I'm going to warn you now, make absolutely no sense whatsoever. Like, for example, right here, W is, write that over, W is tungsten. Okay, and as I said earlier, Ag is silver. All right, AU is gold. So some of these abbreviations won't make sense in English. They relate back to either the Latin names, or sometimes if, other languages were involved in their discovery, such as German or French, then sometimes those languages are the language in which the element was named in, and so that's why the chemical symbols don't always match the English-sounding name for the element. But really, you'll come to make peace with that, and you'll come to understand more or less how to, associate the element name with the symbol the more you practice using the periodic table. So let's do that now. Let's actually practice a little bit using the periodic table. All right, I'm going to try to find the following elements in the periodic table, and I'm going to list their group and also their period numbers. All right, so let's start with the first one. Let's work with sulfur. Okay, so let me switch colors here. All right, so sulfur is this element, letter S. All right, so basically sulfur is in group. If I'm looking for the group, I want the number above the column in which the element is found. That's group 16, and the period number would be found all the way on the left where the period numbers are listed vertically. So sulfur is found in group 16. It's found in period 3. Let's try sodium. Okay, so sodium is one of those elements that don't seem to make sense. I mentioned it earlier. Sodium is Na. Okay, now basically sodium has a place in group 1, and it's also, much like sulfur, in period 3. So sodium is in group 1, and it's also found in period 3. Let's try silicon. Okay, now silicon is actually one of those elements where its abbreviation makes sense. Silicon is Si. Okay, now silicon is in group 14, but also still in period 3. So that would be, silicon would be in group 14, period 3. So one resource I can give you in terms of understanding or learning to understand some of these abbreviations that may not be second nature now is there are those periodic tables on the internet that are searchable. So for example, this is ptable, which is available at ptable.com on the internet. And so what's good about this table is that there's a search box, if you notice up here in the upper right hand corner, where if you would like to find an element quickly and it's sort of taking you a while to go and find an element that has a funny abbreviation that doesn't match the name, ptable can help you with that. So for example, let's try finding mercury. All right, now if you notice, once I type in mercury, it places mercury's box in the periodic table right over here. All right, and it's also put mercury in a gray box so that you can find it more easily. And the other good thing about ptable is that it also allows you to click on the box of an element and actually get a rundown that's linked from Wikipedia of the element and its uses. We will be using ptable from time to time. I encourage you not to get too dependent on it, because when we take tests, you're going to get a hard copy of the periodic table to use. You're not going to get an interactive periodic table that will do the work for you. So we're going to work together this year to get you guys comfortable with using the periodic table on your own. Though certainly for homework assignments or for classwork assignments, by all means feel free to use these interactive periodic tables to assist you in learning. Okay, so if there are any questions, by all means then email me again, or if you'd like, you can speak to me in class. I will see you guys where we will be discussing the periodic table further and doing some additional problems in class to reinforce this idea. All right, have a good night.